Okay, so let me just redo this one. So we've got, what was it? What did I say? Make this one n. So we've got n minus 1 multiplied by n plus 1 minus n squared comes out as n squared minus 1 minus n squared gives me -1. Okay. Next one. We've got, so this is what I was saying. So if the 13th row is 71 and the 19th row is 95, using our formula and just thinking, right, we could say 14th, 15th, we could make the spaces, but basically to get from the 16th to the 19th row, we have to add on 6 lots of whatever we add on. Okay? And that's part of the problem, isn't it? Figuring out what gets added on. But 71 plus 6 lots of whatever that is equals 95. So then we get 6d has to equal 24, which means d must equal 4. Right? So that leads you to however you want to work out. So it says determine the number of seats in the front 3 rows. So I would then go with, well, what do we say? You could either count backwards, if you like, or we can say that un is equal to u1 plus n minus 1 lots of d. So that would, using this again, so 71 is equal to u1 plus 12 lots of 4. D is 4. So 71 is equal to u1 plus 48, which tells you that u1 must equal, what was it? 23? Okay. Then from that point, I know that u2 is 27, u3 is 31. If I add those together, because that's what it said, determine the total number of seats in the front 3 rows combined, I get 81 seats. Okay, makes sense? Any questions on that? No? Quite a few people got it right. So. Yeah. We'll be on the video if you're doing your own time. So you know. I'll pause. Okay. Next question. So we've got nice easy start. Write down the value of the first term and the common ratio. So u1 is 6. R, well, you do 3 divided by 6, or 1.5 divided by 3, but you get the answer a half, yeah, or 0.5, up to you. Right? Write down a recursive formula linking the nth term to the n plus 1 term. So un plus 1 is equal to, well, we know it's geometric, so that means we're multiplying by the ratio. So we should write, well, a half un, or un over 2, or 0.5 un. Okay? We should be beyond the stage now of writing things like un multiplied by 0.5. Okay? Just as a little point, as extended students, we know that when we're using sort of algebraic conventions, we don't do that. Slightly different from the next question, right? Which is write down an explicit formula. Well, we know an explicit formula for a geometric. Well, that's un equals, what is it? u1 r to the power of n minus 1. So now we can, because it's all numbers, we can do it 6. There has to be a multiplied by, and then it's whatever you've got for r. So I would be writing a half in brackets n minus 1, or you could write 6, 0.5 n minus 1, whatever you want to do. Okay? Technically, I wouldn't be correct if I'd have done the fraction and no brackets, because that would have been 1 only. But I don't think that was an issue for anyone. Find the value of the 10th term, correct to 3 significant figures. So u10 is equal to 6 lots of a half to the power of 10 minus 1, and we end up with well, I ended up with 6 over 512, which then is 0.01171,875. Correct to 3. So my tip is always write, I keep telling you, it's always like, always write the unrounded answer first so I can compare. Right? Because if you just wrote this as 0.01, for instance, I can assume you might have got it right, but I don't know. You just rounded wrong. But what we do, so significant figures, no, the zeros don't count in this case. What we do is we look at the number and get the number with the first influence on the value of the number. So that would be the 1. Okay, and once we've started counting, we have to carry on. So 1, 2, 3 significant figures. Okay, they're the ones that give it the value, the first 3 numbers. Then the 1, I forget about the rest. The 1, do we go up or do we keep it the same? Keep it the same. So we end up at 0.0117 to 3 significant figures. Right. Your questions might be, if I had 0.010735, for instance, that to 3 significant figures would be? 0.0107. The 0 does count because once I've started counting, I have to count to the next one. Okay. So just in case it wasn't clear. But that's not for this question. So that's your answer. All good? Any questions? Would you like to pause? Or are we all good? No? Alright. A machine makes components. It does something different in the first hour for whatever reason. Okay? I guess it takes the warming up or whatever. So find the number of components made in the first hour. What do you do? It says first hour, by the end of the second hour it's made. So I go U1, U2, U2 is 6,000, and then by the end of the 7th hour, so U7 is 24,000. Okay? Alright. It says it's a constant number, so that means what type of sequence is it? Arithmetic. Okay? So we can then say that, well, we have to figure out what D is, don't we? So that's how many lots of D? 5. Okay? So I'm going to do it slightly differently from before, so I'm just going to do, okay, what's the difference? So 24,000 subtract 6,000 is? 18,000. If I take that 18,000, divide that by 5, I get the answer 3,600. So that's the D. Okay? I then just need to subtract, not divide, subtract 3,600 from there, and I get 2,400 for U1. Okay, the first number of components made in the first hour. You might have done it in a different way, but it's fine by me this way. Find the number of components made in total over a 9-hour working day. So this is where a couple of people misunderstood the question. All right? So will I ever, do you remember we talked about, do I need to add up the numbers in a series or not? All right? This is a case where each term is actually already the sum of everything, yeah? So 2,400 is how many I've made after an hour. Okay? 6,000 is how many I've made in 2 hours. Don't add those together. So in 9 hours, I need to be doing just finding the 9th term. So that's U1 is 2,400 plus 8 lots of 3,600, and I get the answer 1,002. So that's the 9th term. Alright? We wouldn't then add everything together. We don't need a sum of. Alright? All good? Any questions? Right. Geometric sequence has second term 30, third term 45. Find its first term, write down the expression. Easy enough, right? It's geometric, so we need to find out what we multiply by. So we just do 45 divided by 30, and we end up with 3 over 2 or 1.5. Yeah? So then to find u1, I can just do, well, u1, that was 30, this is 45. So I'm just going to divide by 1.5, and I get 20. So then, expression for the nth term is just un equals 20 multiplied by, well, I've got 3 over 2 to the power of n minus 1. You might have 1.5. Generally not too bad, yeah? Easy enough. The one that caused some people the problem, maybe. Okay, so we need to figure out when is the first time that 20 multiplied by, I go to 1.5, n minus 1, has to be greater than 1,000. That's what we're trying to solve, which value of n. So if I simplify, I'm going to divide through by 20, up to you if you do this or not, 1.5 minus 1, greater than 50, and then trial and error methods is what I was expecting in this case, because we've not got logarithms, and you end up getting to, well, if n is equal to 10, we get 768.867, and when n is 11, we get 153.3.
So you're telling me, how was I so wrong?
So how do I do that? Just chuck it into my calculator here. I'll end up with 1.5 to the power of 9 will give me this.
Oh, yeah.
So therefore n is 10. Yeah? So I'm just, because I've simplified, I don't need the 1,000 anymore. Let's have I got my calculator to show you? So literally on my calculator, I would just be doing 1.5 to the power of, I'd have a guess. Let's say I guess at 7 and I get that. Okay, I need to go further. So I'm going to do 1.5 to the power of 9. Okay. Now notice that I want 50, not 1,000 now, because I've simplified it. So I've got 1.5 to the power of 10 gives me 57. So therefore, I now know that n minus 1, the first time it's over 50, because I've simplified, is when n minus 1 is 10. And if n minus 1 is 10, n has to be 11. Now what I then did was I chucked that back into the original one and just checked that that gives me numbers over 1,000. That's where these two numbers come from. Okay? And it does work. Yeah, do you know what your mistake was then? Yeah?
Like how? I don't understand.
No good? Yeah, everyone good? From writing or from forms? No? Okay. A geometric series begins like this and has 8 terms. Find the total of the series. So we're then looking at the sum. The formula that you're going to use is u1 to rn minus 1 divided by r minus 1, yeah? So we've got the sum of 8, not that, it's not infinity. The sum of 8 terms is u1 is 8, multiplied by, well, 12 divided by 8 is actually 1.5 again. So I've got 1.5 to the power of 8 minus 1, all divided by 1.5 minus 1. So the sum of 8 terms, and you end up just evaluating that, and you get using the formulas.
Yeah, so that's my biggest issue.
It is a common one. It's not just, you know, even when people get given the formulas,
Yeah, my issue is.
using the correct ones. Yeah?
Yeah.
It's a skill, actually. It's why I would say if I give you a formula booklet, like I give the DP students a formula booklet, I say every lesson get your formula booklet out so you can see what's in it. Because if the first time you actually see your formula booklet is when you need it in an exam, you won't do it correctly. Same as all your tools. Right? Find a fraction equivalent, so this is my free copy, that's right, should be recurring. Now for this one, actually, if you just remembered that it's 123 over 999, that's enough.
I remembered it, but I thought that that would not be good for the fancy. So
Well, it just says find a fraction. I've not said show how you do it or anything. I just, like, there are other methods you could have done it. We went through a couple of phases, yeah. I didn't even need you to simplify it. Find a fraction that is equivalent. Any fraction would have done that's equivalent to it.
I just solved.
Wait,
Alright.
we could have put that in our calculator.
Yeah.
It was just one of those questions I took from the book and I thought, oh, I'll see what they remember. So if they remember, it takes 1 second to write the answer down. If they don't, it might take them a while and they might freak out a little bit. But if you want to go through the methods, remember we said x was 0.123, 123, 123. So then we want to multiply by 1,000. So that would be 123.123. And so on. We then subtract, so we've got 999 x's is 123, divide by 999, and we get x is 123 over 999. No need to simplify, it is the fraction. Okay? How long have we got? Plenty of time. These are quite good. I think you've got these, didn't you? I thought it might trick you up. Well, this one's alright now. An infinite series. Okay, what's the formula for an infinite series? U1 over
1 minus r.
1 minus r. So we know that the sum is 15 and the first term is 10. Find the value. So we just put 15 equals 10 divided by 1 minus r. So if I multiply through by 1 minus r, I get 15 multiplied by 1 minus r equals 10. And then if I divide by 15, I get 1 minus r is 10 divided by 15, the basic algebra. Then obviously I can add r and subtract if you like, but I end up with 1 minus is equal to r, which means r is equal to 5/15 or 1/3. Okay? All good with what I just did there? That sets you up for the next one. I think the last, is it the last one, wasn't it?
Yeah.
Yeah. So the last one was really checking for the top end whether you remember how to deal with your algebra. But it leads on from the previous question. So same thing again. Geometric first term, the sum to infinity, so we got S infinity is U1, 1 minus R, so we set it up now. So we've got 100 divided by 3 is equal to U1 is X divided by 1 minus, now the ratio is U2 divided by U1, yeah? So R is X minus 3 divided by X. So I need to put that in there. X minus 3. Now I saw quite a few of you had this. So that's not a bad start. That's what you do from here. So me, personally, I sorted out the denominator first. So I am going to simplify 1 minus x minus 3 over x. And I'm going to do that by converting to the same denominator. So that's x over x minus x minus 3 over x. Okay? You with me so far? All good? Yeah? So what do I do? This should be alarm bells, by the way. Why? Negatives and negatives always should make you double check.
Why?
Why? Because I keep telling you,
Why is it negative?
you are subtracting a negative, which means this becomes, right, there should be a bracket, it becomes x minus 3 all over x, okay, which is then x subtract x but plus 3 all over x, which is then just 3 over x. Right? I believe someone, was it you, had negative 3 over x? Or was it you?
300 over
Some-
three.
Okay. Someone had a right step but had a negative here like this. Oh yeah, was it you that just suddenly forgot the x? It just disappeared.
I don't know, but I don't understand.
I think when I figured out what you'd done, and there was just an X disappeared. That was the only.
No, but you have an X circled and then it says question mark.
Yeah, where did it go? Basically, that's what I said.
Could not.
So then this here is just replacing all of this, right? So now I've got 100 divided by 3 is equal to x divided by 3 divided by x. Now what do you do if you divide by a fraction? Time. So we've got x multiplied by the fraction, the reciprocal, so x divided by 3. Which then becomes 100 divided by 3 equals x squared divided by 3, which means x squared is equal to 100.
So I put 100 equals X.
So
Well, the
x
x
is 10.
went, that's what I'm
So
saying.
x is
I
You
hate
had a
this.
divide by x and you just let it disappear. If you had then multiplied 3 by your x, you'd have ended up with x squared equals 100.
Yeah.
So now we get x has to equal
10.
10. Now, question for you is what about negative 10? 'Cause-
It's not. It's not right.
no?
I don't know. I didn't
It's not
yeah.
getting closer to 0. Wait, no, it is.
Ah,
It's
so
10.
remember what x is. So remember what we've said. X is the first term, x minus 3 is the second term. Okay? So we're basically saying 10 and then the next term would be
7.
7. Okay? So on, yeah?
But then it could also be negative 10 and negative.
So it'd be negative 10 and then negative 13. Now, in that case, could this option as a sequence carry on? And if I add those together, go be a sum to infinity? Is it possible? Should I give both answers as possible? Or is X, is 10 the only option? Because this should work, right? This is going to get smaller and smaller.
Wait, what is R?
You tell me, yeah.
Because if we were to do
X minus 3 over X.
Well, now we don't
No.
need to. R,
It
in
wouldn't
this
work.
case, is 7
R
over
is
10.
different in the
And this
negative
one,
That's
R
one-
is
1.3.
1.3.
So it's not right.
So this one, why is it going to work?
R is greater than 1.
R is greater than 1, isn't it? R is greater than 1. So we can't do that one. So this one, I'm good with. So no, negative 10 is not a possible option. But at your level, with a question like this, that should be something you're thinking about. Alright? Because sometimes it will be an option. If you don't give it, you lose credit. You lose marks. Alright? If it's not an option, you should be able to show it's not up. You should know by now and be fully aware that you have to consider, if I end up with x squared equals 100, there are two possible values, but it's whether they are applicable or not. And in sequences, they often are, because your r value could be positive, but it could also be negative. You know, if r squared equals 4, r could be 2 or negative 2. And it would still work. So especially in sequences, make sure you consider x squared. But in this case, being that x is what we had to find, x can be 10, but x can't be negative 10. So this was the top end question, real the challenge, to get it done really well and properly.